Hey, good morning, class, and welcome to lesson 5.2.3. How can I solve it? The objective today will be to solve exponential and logarithmic equations. Let's take a quick review on some of the stuff that you've covered in the last lesson or two. Basic properties of logs. Remember, log base b of b equaling 1, by definition, is b to the 1 power has to equal b. That's a true statement. In other words, if I have the log base b, let me choose a different base, log base 3 of 3, what does that have to equal? Well, 3 to what power equals 3? Well, that value has to be 1. Down here, log base b of 1 equals 0. By definition, b has to be raised to the 0 power in order to have an output of 1. That's why there's a 0 over there. On the left side, that's really read as b to some power has to equal 1. Well, that power has to be 0. Now let's take a look at log base b of b to the x. Now I'm going to take and look at this just a little bit differently than the other two. Let's just look at the left side of that. That is asking us b to what power, draw a little arrow here, b to what power equals b to the x. Well, this exponent over here has to be x. So those are your 3 basic properties. And there was a few others that we explored in the last lesson, like the product property, the log base b of x times y is equal to the log base b of x plus the log base b of y. Now if I take the log base b of x divided by y, that's equal to the log base b of the numerator minus the log base b of the denominator. In our last one, the power property, this is one of my favorites. Log base b of x to the n has to equal n times the log base b of x. Now just a little bit more of an explanation on that power property. If I have the log, I'm going to say base 10 of x to the 5th power, isn't that really the same as the log base 10 of x times x times x times x times x, which by the product property is really the log of x plus 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 the log of x, and log of x plus log of x plus log of x plus log of x plus log of x is 5 log x. That's another way to look at this power property. The log of x to the 5th power has to be the same as 5 times the log of x. Now that was a review of our properties. Let's get on to solving some logarithmic exponential equations. How can the relationship between logarithms and exponents be used to solve equations? This lesson will give you practice with solving equations with exponential and logarithms, exponents and logarithms. Question 579. Eduardo thinks he can solve x to the 6th equaling 20 in just one step. He says the solution is x equaling log base 6 of 20. Is Eduardo correct? Explain why or why not. Yeah, he's for sure correct. By our, let me go back to a different color. By our definition of logs, my base is 6, so log base 6 of 20 has to equal x. Now we can just type that into our calculator. But our calculators can't always calculate the log base 6 of 20. So is he correct? Yes, he is correct by the definition of logarithms. Is it practical? No, because we cannot easily solve log base 6 of 20. Now Anita says she knows how to solve 6 to the x equaling 20 using logarithms in another way. She tells Eduardo to start by taking the log base 10 of both sides and then apply the power of logarithms, power property of logarithms. So here's what Anita is saying. If I take 6 to the x equaling 20, and I'm going to leave a little bit of room here, then if I take the log of both sides, log of the left and the log of the right, I now can pull this exponent of x out in front. So I now have x times the log of 6 equaling the log of 20, which, if I divide both sides by the log of 6, the log of 20 divided by the log of 6. Now take your calculator and type that in, and let's see what you get. Because you do have a log button on your calculator, or a common log button. So you can go the log of 20 divided by the log of 6, and you should get 1.672. Now when you do this on your calculator, make sure you use a closed parenthesis for the log of 20 and the log of 6. Eduardo's older brother, Lemuel, is taking calculus. Looks at Eduardo's equation and says, just take the natural log of both sides. Try Lemuel's method. Does that work? You bet that's going to work. It's just using a different base. So if I take 6 to the x equals 20, but now I'm going to take the natural log of both sides. That still allows me to pull the x out in front. So now I have x times the natural log of 6 equaling the natural log of 20. Divide both sides by the natural log of 6, and x equals the natural log of 20 divided by the natural log of 6. Now type this into your calculator, making sure you use parentheses, and you will get 1.672. All right, let's try a few of these. Solve each of the following equations using the method of your choice. Begin by estimating the solution, then solve the equation and give both an exact answer and an approximate answer. Be ready to share your strategies with the class. Okay, so let's take a look at this first one. Let's start by trying to approximate an answer. I've got 1.05 raised to the power of x. Well, is that going to be squaring it? So 1.05 times 1.05, just without even using the calculator, that's going to be a little bit above 1. So I'm guessing it's going to almost be double digits. So take your calculator, let's just estimate 1.05 raised to the 10th power. Hey, 1.62, we're getting there. Remember, we're always taking 1.05 times 1.05, however many times we have for x. So let's jump up and try maybe 15, 1.05 raised to 15th power. Oh, that's a pretty good estimate. So 1.05 to the 15th power is 2.07. So x It has to be less than 15, but it's going to have to be greater than 14. So let's figure out what that value happens to be. 1.05 to the x equaling 2. Now I'm going to take the log of both sides. That's going to pull that exponent out in front. And then I'm going to divide both sides by the log of 1.05. And x equals log of 2 divided by the log of 1.05, which is equal to 14.207. Now, B and C, I'm going to have you try those on your own. In the process of doing this, think about how we were able to take the log of both sides over here. I was able to take the log of both sides because I had my base of 1.05 raised to the x by itself. You need to get the 3 to the x by itself by getting rid of the 15. Over here, you need to get the 10 to the x by itself by getting rid of the negative 12 and getting rid of the 3. So think about solving equations, get your base by itself, and then you can take the log of both sides. So pause this, try those on your own, then come back and check your work. Okay, welcome back. Now if we take a look at part B, we have 15 times 3 to the x equaling a negative 6, divide both sides by 15, and we get 3 to the x equaling a negative 6/15. Before we finish this, I saw a little bit of an issue right here, but I went and finished the problem anyway, and maybe you did too. How can a positive number raised to the x ever equal a negative 6/15? In other words, how can that 3 to the x ever equal a negative number? It can't. So right here, I know that there's no solution. But if you finished the problem, you would have then taken the log of both sides, pulled the x out in front, then divided both sides by the log of 3. And if you tried to calculate that, you cannot take the log of a negative number in the numerator. So you get no solution. Now in part C, start by subtracting 3 from both sides. Then divide both sides by negative 12. Then you're going to want to take the log of both sides, and that pulls your x out in front. What I did is, at this point, the log of 10, if you type that into your calculator, you get 1. Because this is really saying, right here, log of 10 is saying 10 to what power gives me 10? Well, that's 10 to the 1. That's one of the properties on the first slide of the lesson. So that number right there is really 1 times x gives me x equaling the log of 1/2. Take the log of 1/2 in your calculator and get a negative 3.01. Now, before we move on to the next slide, I want to talk just one more, or make one more point of emphasis. Many students, right here is the number one mistake that we end up seeing. Students take a negative 12 times 10 to the x, and they multiply that together, and they write this then as a negative 120 to the x plus 3 equals a negative 3. And then they go in and try to solve it. You cannot multiply those together because this is really asking or telling you take 10 to some power, or take 10, multiply it to itself so many times, then take that value and multiply by negative 12. So your order of operations say is you have to take 10 to the x before you can multiply by negative 12. So be aware of that as we work more of these and as you encounter these problems in homework and on your test. Solving more logarithmic equations. Use what you've learned about the relationship between exponents and logarithms and the properties of logarithms to solve each of the following equations. Give exact solutions. All right, so here's what I know. I've got the log base 7 of x squared and the log base 7 of 8x minus 15. If I'm taking the log of the left side, and I'm taking the log of the right side, then what's in those parentheses, that has to be equal, because this operation out here is the same as this operation. So let's get rid of that operation and just write this as x squared equaling 8x minus 15. Now I'm going to take x squared, I'm going to subtract 8x from both sides, I'm going to add 15 to both sides, and that equals 0. I'm going to factor this, and I think you'll end up with x minus 5 and x minus 3 equaling 0. So that means x has to equal 5, x has to equal 3. Now let's go back and double check our solutions. Plug 5 in for x. Make sure everything works out. So I have the log base 7 of 5 squared, which is 25, and that's going to equal the log base 7 of 8 times 5, which is 40, minus 15, which is 25. I can take the log base 7 of a positive number. And that's going to be key. This has to be positive in here. Now let's try that with 3. Log base 7 of 3 squared is 9, equaling the log base 7 of 8 times 3, which is 24, minus 15, which is 9. So all I did is I took that 3, plugged it in there, plugged it in there. Answers check out. Now for part B, log base 2 of x cubed plus the log base 2 of x minus the log base 2 of 2x. Using those properties from the very first page, here I'm adding 2 logs. If I'm adding 2 logs of the same base, 2, then I have to multiply the values inside the parentheses. So this is really the log base 2 of x to the 4th. Now the minus log base 2 of 2x gives us dividing by 2x. So remember, when you subtract logs of the same base, that's like dividing their values inside the parentheses. Equals 6. Now I'm going to simplify what's inside the parentheses. So this is log base 2 of x to the 4th, divided by x is x cubed over 2 equaling 6. So now by definition of logs, my base is 2, that has to be raised to the 6th power, and that's going to equal x cubed over 2. Now let's solve for x. Multiply both sides by 2. I have 2 to the 7th power, which is, well, 2 to the 6th times 2, or 2 to the 7th power, which is 128, equaling x cubed. And now I'm going to raise both sides to the 1/3 power. If you want to take the cubed root, that's fine. Remember, that's the same as the cubed root of 128. So x equals the cubed root of 128. Remember, they wanted exact solutions, no decimals. Now, if I take and plug the cubed root of 128 back in here, everything will check out. You can go ahead and do it, but in the interest of time, I'm not going to right now. Now, these next two, what I'm going to do is I'm going to give you a couple of hints, then I'm going to have you pause it. You can work on them, and then come back and check your answers. Hints. You are adding two logs. Therefore, you're going to take the log base 7 of something times something, and then go from there. Over here in part D, you have 3 times the ln of x equaling ln of e to the 5th. If you go back to the first page, if I rewrite this, this is really kind of like the log base e of e to the 5th. Well, that has to equal 5. And again, that's a property on the first page. These undo each other. So this is really 5 minus 2 equals, and you take it from there. So pause this, finish the problems, and then come back and check your work. Okay, welcome back. Here in part C, log base 7 of x minus 4 times x plus 2. So I have to take this x minus 4 and multiply it to this x plus 2, and I get x squared minus 2x minus 8. My base is 7, so 7 raised to the first power has to equal everything inside the parentheses. So I have x squared minus 2x minus 8 equaling 7. Subtract a 7 from both sides. That leaves me with x squared minus 2x minus 15. Factor that, x minus 5 times x plus 3. And my two solutions are x equaling 5 and x equaling negative 3. But please go back and check your work. So I'm going to plug 5 in there. So the log base 7 of 5 minus 4 plus the log base 7 of 5 plus 2 equals 1. Well, this becomes the log base 7 of 1 plus the log base 7 of 7. You can check it. It does work out. You can type it in your calculator. But here's what we need to really focus on. Negative 3. Can x be a negative 3? So I'll plug this in. I have the log base 7 of a negative 3 minus 4 plus the log base 7 of a negative 3 plus 2 equaling 1. Okay, so I slid that up to give us a little more room. And so now the log base 7 of a negative 7 plus the log base 7 of a negative 1 equals 1. You can't take the log base 7 of a negative 7 because this is really asking 7 to what power gives you a negative 7. Well, there isn't an exponent that will do that. You can't get a negative output when you start with a positive base. And the same here. So this is what we call one of those extraneous solutions. back to part D. 3 times ln of x has to equal 3. Divide both sides by 3. Those 3's cancel. You're left with the ln of x equaling 1, which means, by definition, e raised to the first power has to equal x. Therefore, x is e. Plug that back in there. And the ln of e is 1 times 3 equals, well, we already know that the ln of e is 1, or they undo each other. That would be another way to look at this side. And so now I have 5 minus 2, and that gives me 3 equaling 3. So it does check out for part D. Our last two problems, what I'd like you to do is pause this after I give you a couple hints, and then solve the problems, and then come back and check your work. In part E, start by dividing, or divide both sides by -9, then use your definition of logs. In part F, you have the difference of two logs. So this is going to be the ln of something divided by something equaling 10. So those are your hints. Pause this, do your work, come back and check it. Okay, class, welcome back. Part E, first divide both sides by a -9. So now you have the ln of x plus 1 equaling a -8 over a -9. By the definition of logs, my base is e here, so I'm going to take e, I'm going to raise it to this positive 8/9, and that has to equal what's inside the parentheses, x plus 1. Subtract 1 from both sides, and x equals e to the 8/9 minus 1. Now if you want to turn that into a decimal, that's fine. I just left it in that form to help emphasize a couple of properties when we are checking our work. So now let's check our work by plugging this value back in for x. So I have a -9 times the ln of e to the 8/9 minus 1 plus 1. Well, the minus 1 plus 1, they undo each other. And that leaves us with just e to the 8/9 inside the parentheses. So on the outside, divide by -9. And so now you have the ln of e raised to the 8/9 equaling a -8 over -9. A -8 over -9 is just 8/9. And on the left side, this ln of e, the property is they undo each other, and you are left with just the 8/9. Now in part F, go through, if you have the ln of x plus 8 minus the ln of x minus 4, then that's going to be the ln of x plus 8 over x minus 4 equaling 10. Again, by definition, our base is e, so e raised to the 10th power has to equal everything inside the parentheses. Get rid of your fractions by multiplying by x minus 4. They cancel on the right side, leaving you with x plus 8. On the left side, you have x minus 4 times e to the 10th. Now, if you want to turn that into a number, that's fine. I'm not going to yet. I'm going to distribute. And so I have e to the 10th times x minus 4 times e to the 10th. Get your x terms onto one side, get your numeric values onto the other. So I'm going to add and subtract an x from both sides. So that gives me e to the 10th times x minus x. And then I'm going to add this 4 e to the 10th to both sides. So on the right side I have 8 plus 4 e to the 10th. That comes out to be 88,113.88. On the left side, e to the 10th minus 1 gives me 22,025.47 times x. Divide by that 22,025.47 and x comes out to be 4. Plug that in, check your work. 10 equals 10. If you want to pause this and look back through it, that's fine. That is the end of the lesson. Everybody, thank you for your time watching these videos. And if there's questions that you have, please email your teacher or contact your teacher during office hours. Wishing you all the best. Remember, you do have a test coming up on Thursday for Chapter 5. We have one more lesson tomorrow on Tuesday, Lesson 5.2.4, a review on Wednesday, and then that test. I wish you all the best. Have a great week.